Welcome, my dear students. Let us continue our discussion atomic structure. Here I will come up with another atomic model that is called the quantum mechanical model of atom. This is the final model of atom. It's a very complicated one. When you see the syllabus, Schrödinger wave equation mention only. That is a syllabus, just mentioning. Therefore, I am not going in detail of the model. For physics students, they will learn the detail in their physics syllabus. For zoology and botany, it's just for namesake only. Quantum mechanical model. This is a model where electron is a wave as well as particle. Where electron is not a particle like in Bohr model. In this model, electron has dual behavior. Remember, in this model, electrons have dual behavior, and therefore, in Bohr model, we have discussed that electron is revolving around the nucleus. That does not happen here. Here you have orbital. I will explain what is orbital. O-R-B-I-T-A-L, orbital. Orbit, orbital. Orbital is a three-dimensional space around the nucleus where electrons are most probably seen. Anyway, in this model, electron has been described. Properties of electron has been described by an equation called Schrödinger wave equation. Schrödinger wave equation is a differential equation, three-dimensional differential equation. It's a three-dimensional differential equation to describe the properties of electrons. What is Schrödinger wave equation? It's a three-dimensional differential equation to describe the properties of electron. This is dou. This is called dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m divided by h square e minus v into psi is equal to 0, where m is the mass of electron, h is the Planck's constant, E is total energy of the electron, V is potential energy of the electron, psi is wave function of electron. We said that electron has a wave character. When electron moves, it moves like a wave, like sine wave, cos wave, water wave. It moves like a wave. That wave has a mathematical function that is called psi. If you specifically ask me what is psi, psi is the amplitude of the wave. Suppose this is an electron wave. This is an electron wave. Psi is the amplitude of the wave. This equation is also written as like this. This is called del kappa square. And this square differential, no psi here, this entire thing. That is, suppose we take all these things, then put a psi, that happened here. And this is called kappa. Okay. Now, this is also written as like this, h psi is equal to E psi, where h is called a Hamiltonian operator, H is Hamiltonian operator. Therefore, this is a three ways you can write the Schrödinger wave equation. This is the one way, this is the second way, and previous one was the first way. Three ways you can write the Schrödinger wave equation. What is a Schrödinger wave equation? It's a three-dimensional equation. It is a three-dimensional equation describing properties of electron. Describing properties of electrons. It's a three-dimensional equation describing properties of electrons. According to Schrödinger equation, electron is wave. Electron has wave property. Electron has wave property. Now there is a definition. What is orbital? What is orbital? Orbital. Okay. Now, in this model, we have orbital. It's a three-dimensional. It is a three-dimensional space around the nucleus, where electrons are most probably seen. Electrons are most probably seen. It's a three-dimensional space around the nucleus where electrons are most probably seen. This is what is we called orbital. Fine. Orbit and orbital. Differentiate between orbit and orbitals. Orbit and orbit. This is orbit. This is orbital. What are the difference? So two-dimensional. This is three-dimensional space. This is a two-dimensional circle around the nucleus. Two-dimensional circle around the nucleus. This is three-dimensional space around the nucleus. Yes. It is in Bohr model. This is in quantum mechanical model. This is quantum mechanical model. It does not follow. Doesn't follow uncertainty principle. Uncertainty principle. It follows uncertainty principle. Okay. It is very specific, very specific and fixed. It is non-specific, non-fixed. Okay, this is the difference between orbit and orbitals. Now we will go to next topics, very, very important topics, quantum numbers. Quantum numbers. Quantum numbers.